Hello, welcome to the final Entity Framework Community Stand-Up of the year. We have a bit of a festive theme this week, as you might be able to see. And most of the show, we're going to be talking hot chocolate with Michael Staib, which is the GraphQL library for .NET. So we all have our mugs of hot chocolate. Or at least we're pretending they're hot chocolate. I think Jeremy actually really has hot chocolate in his, because he's not a fake. He's keeping it real for us.
This is legit for sure.
Yeah. So before we do that, we'll just do the final state of the unicorn for the year. Now, Shai suggested that we should do state of the reindeer, but I couldn't do it because I'm just too much of a fan. Too much
graphics effort.
So instead, we have just reindeer. We have unicorns pulling the sleigh. I think this is something you're going to see for the first time this year. Unicorns on the sleigh. This year's all been about EF Core 6.0, released in November, about 3 weeks ago. Jeremy published a blog post just this last week, Get to Know EF Core 6. Let me see if I can quickly show you this. So this is on the .NET blog. And on here, there's videos and links to videos and docs and everything that you want to know. So we have videos and docs for Cosmos DB stuff. We did a bunch of Cosmos DB stuff in there. Compiled models, great feature from Andrew to improve your startup time. Configuring conventions, again, from Andrew, helps your model building. Migration bundles, Bryce has been working really hard to get that. People seem to love it. Shai done a lot of performance stuff here. And temporal tables from Marisi. And then, of course, Smith, as always, does all of the great query stuff, even though it's not on the list here because it's so fundamental to everything. And then, of course, we've got GraphQL links on there because GraphQL works great in .NET, and that's what we're going to talk about today. Just want to point out we've been on NuGet for just over 3 weeks. We're at 400,000 downloads already for EF Core 6.0. So thank you to everybody who's downloaded it and tried it and submitted issues and questions. It's been great. So next year will be about EF7. and we've got the plan ready. It's going to be reviewed by the big wigs, the .NET directors, next week, and then we'll put it up on GitHub and in the docs for everybody to see and give feedback on. And as always, it's a continually evolving plan. So just because we publish something doesn't mean we don't want your feedback on what other things we can do. So look out for that in probably next week sometime. And with that, let's go over to GraphQL. So Michael, what have you got to show us today?
Yeah, I have lots of little demos where we will look at the state now with .NET 6 and EF Core 6, and also a bit into the end of year release into 12.4. And we are making Entity Framework more easily to use in Hot Chocolate going forward.
Awesome.
It was already pretty easy to use, but
yes.
It will be easier and less clutter. But yeah, we can start.
Okay, let me share this here. Okay.
Yeah, as always, I start with an empty console. And the first thing we added now with Hot Chocolate 12 are better templates that align with .NET 6. And this is really great to get you started with either ASP.NET Core, which we support for a while now, but also with Azure Functions. And we're starting with Hot Chocolate 12.3, I think, we start to ship Azure Functions support. So if you're into Azure Functions, it's now super easy to start. Let me just jump into my first demo, and then we can just have a look at some code. So in order to get the templates for Hot Chocolate, you just start with your console, .NET New, -i, and then you essentially type in the templates package. That works actually with a lot of templates that are out there and supported by the community. And the cool stuff is that actually these templates then show up in Visual Studio. So if you don't like Visual Studio Code like I do, and you want to run these templates in Visual Studio for Windows or Visual Studio for Mac, just install it with the console and you're good to go. So what we are doing here is Hot Chocolate .templates. And then we are taking the leading edge stuff here. Give you, I think it's 14.
14 previews, wow.
Yeah, we are doing them. Tons of them. So what you can see is now I just installed here my templates. I have a Hot Chocolate GraphQL function template, which is essentially Azure Functions 4, or I have my Hot Chocolate GraphQL server here. And it's quite easy to get started with Azure Functions. So I just say now .NET New, GraphQL, Azure Functions, and we are good to go. Have a look at that.
Awesome.
Yeah.
It's very cool that you can just add your own templates as NuGet packages and have them integrate into .NET like this. This is something that I remember there was a lot of talk about when we were doing .NET Core. Let's make it so that people can publish NuGet packages with their own templates, and you're not limited to whatever you've got installed in Visual Studio. You can use them from the command line. Other people can add them. So love seeing this working.
Yeah, it makes it so much easier, like the startup experience. Like before, it was fixed what is in Visual Studio, and as a community project, you weren't able to get any of your templates in there. Now it's so easy. It's one line of shell script, and you're good to go. So what we can see here is now I have my Azure Functions project, and I can see there is a query, like any query for our GraphQL server. And you can see it's already .NET 6, so we have these file scope namespaces here. And we have lots of other things here, like there's a startup. The startup is actually just a hook into Azure Functions that configures my GraphQL server. And in here, I can just define my GraphQL. So
that's just an assembly level attribute that you've just put anywhere in your assembly, basically.
Yeah, you essentially, it's just a standard class library. This is so there are two experiences in Azure Functions. This is the out of process. This is the in process experience.
Right.
And that essentially just integrated in assembly. So this will handle, like in Azure, any other GraphQL server, the configuration. Instead of add GraphQL server, we have add GraphQL function here. And the function integration, essentially, let me just restore that. So it looks a bit nicer.
Remove all those squigglies.
Yes.
There we go.
Yay.
Looks much better. And this is essentially a standard function. It exposes our GraphQL server as an Azure function through an HTTP trigger, and essentially gives all the requests onto our GraphQL executor that we wrote for Azure Functions. So in order to start that, we can go here on the Azure symbol and then just initialize our Azure function. And I hope it works. Looks good. This is, by the way, also very awesome. This is a plugin for Visual Studio Code for Azure. It integrates Azure Functions and all the other resources that you have in Azure.
Very nice.
With this, we are good to go, and we can just say func start, which is the Azure Functions console CLI to get started with it. Okay, so our function is already running. I can just grab this URL here and open just a standard browser, put it in, and you get started with Banana Cake Pop, our GraphQL IDE. So when when I thought about Azure Functions, I actually always thought about some HTTP triggers that do one thing. But actually, it turns out you can do a whole lot of stuff with Azure Functions. This is essentially a full web server running in there, serving out the GraphQL interface, the GraphQL IDE, and also our GraphQL server. So I can just query this, and see I have Luke Skywalker. So that is pretty easy now to get started with Azure Functions to host a GraphQL server very cheaply on Azure.
So what does the experience look like if, let's say, we have multiple concurrent hits at the same time? What is shared? What's not shared? What's the startup time look like?
Oh, so you saw the startup time here is a bit about 49. You have a little bit of overhead for the startup, but this, to be honest, it's not a big schema. So if you have entity framework under there with a large database schema or stuff like that, you will have higher startup times. There are solutions to that. So you can either go for a premium plan where you have warmed up workers and others. So there are delayed startups, or you split your schemas onto multiple functions and essentially merge them on one Azure function. So you have a smaller startup time because you're only initializing the parts that you need. So there are a couple of approaches to that. There's also the biggest problem is actually GraphQL subscriptions. But there is a new service on Azure Function on Azure that is called Azure Webpack Sub, and we are integrating that at the moment. So we have already a prototype, and I hope that is going also into 12.4. And then you are able to offload these real-time connections to Azure Webpack Sub and be able.
So for our audience, subscriptions in GraphQL, just to make that clear, is instead of just issuing a query in GraphQL and getting the response back, you subscribe to data that's going to come back to you, and it's going to come back like in real time as a flow, right? As a stream of data.
Exactly. Yeah, we dove in already in the complex stuff around real-time GraphQL. Sorry for that, but it's an often asked question. Okay, you can run on Azure Functions, but you can only do simple fetches. It turns out now you can handle all the complex stuff.
That's very cool. That's
Yeah.
very cool. You can integrate with this. That's
So
very.
does the defer, is that supported as well?
Yes, and we look in this, I think in my demo 5 or something.
Okay.
Okay, so this is just getting started for most of the people. So if you want to do Azure Functions, host it very cheaply. Don't pay for a GraphQL server that nobody uses at the moment, or that scales very to a lot of pressure that you have on your API. That you can do now with our Azure Functions template.
Very nice.
Okay, so let's dive into some entity framework. And with entity framework, let's go to my demo 2. We had a couple of things that we thought are a bit difficult, or when people start getting into hot chocolate and entity framework, there are a couple of things people got confused or had problems with. So the first thing is, if we look at this query type here, we can see we have this resolver. The resolver is essentially a field in GraphQL that fetches data. And here we can see we have the books context, a very simple books context that has an entity books and authors on it. And we are just fetching it and returning it. What we also have...
Book context is just a normal entity framework core DBContext that everybody knows, right? Just to make that clear.
Let's have a look.
And do we not need the service attribute anymore, or are you getting to that?
We are getting to that.
Okay. I won't jump too far ahead then.
So we have the simple books context. I think I showed that the last time I was here. So, and then we have authors and books. So very, very basic.
Basic, yeah.
Yeah.
But many to many, so it's not just a flat model at least.
There's a lot going on under the covers, even though it looks basic.
Yep.
Yeah. And we will see that. I have some joy in the projections demo. You will see how awesome entity framework actually is. But let's not get ahead of ourselves. So the first thing here, this is a simple resolver. We have here our middlewares for projections, for filtering, for sorting, which essentially allows us to rewrite GraphQL queries into entity framework expressions, which we put on top of iQueryable, and entity framework will then rewrite that to proper SQL. And in the past, we told people, okay, so you have essentially 2 ways to do that. You either can use pooling, because then we can execute in parallel with multiple contexts in GraphQL, or you can write something like the serial attribute on here and say, this is actually a service, and then we would inject that and handle everything from there. The issue with that is you would do that on all your resolvers, and it's a bit clumsy. So what we thought about is, first we want to get rid of these things and be able to centralize the configuration, because, I mean, in your GraphQL API, you just have a couple of DBContext, maybe one, maybe more. So let's centralize that. So here you have your DBContext configuration that you do with just Microsoft's dependency injection integration. And then on the GraphQL side of things, you can now say, okay, I register the DBContext that is on top of there. So now we know the DBContext, and now we know how you want to use it. So the default for us, and we can change that here, is that we use a synchronized context, which means by default, if you do add DBContext here, you get a scoped DBContext per request. Mm-hmm. That means we have to tell the GraphQL engine actually that there is only one DBContext and we cannot access it with multiple threads. So the default in this case is that we use it synchronized. So you don't have to specify that. We actually do that for you.
So does that mean then that you're essentially making sure that that context is only used by one GraphQL query at a time?
Yeah, but we
Okay.
let me just get another window, and then we see what it does. So here we have, let me just refresh the schema. Here we have two fields. In GraphQL, in a query, we would parallelize the data fetching and fetch essentially with two threads from books. With a standard DBContext injected into your dependency injection, we couldn't do that. So we would need to synchronize that. And that is essentially what we by default will do. So you can see AB, there's no error. And if we look here at our query plan, what GraphQL does, it creates a serial shape and then executes first this subtree and then the other subtree. But that is also a problem because sometimes you want to scale much more and you want to have more throughput. So with Entity Framework, we actually have a solution for that. And that is a pooled DBContext. So we could say we want a pooled DBContext factory. And this allows us to have multiple DBContexts, initialize them when needed, and then give them back to a pool. And in throughput tests, we can see that it's a lot less memory that you use then. If you can use it, there are cases where this might not be a solution for you. But then you can put a lot more throughput on your GraphQL API.
So do you automatically discover whether or not there's a factory registered in DI and then change behavior based on that?
Not yet. We are.
Oh, you have to change that to pooled.
Yeah.
Okay, that makes sense.
So you
That's very cool.
Yeah, you do it at a central point now in this configuration, and all your resolvers, all your code is now reconfigured. And what it does now is that essentially we automatically build a middleware around this field, which will get a pool, execute get books, and at the end, when this is finished, we will return that DBContext back to its pool. So we handle all the complexity around that behavior. So the standard question that comes now from my friends that do clean architecture is that they don't have direct access to the DBContext. It's behind some services.
Mm-hmm.
And that's no problem for us because you can do the same thing with services by just saying, okay, I register one of those special services. I don't have one of those, but it's the same way. And then you can also say, this is actually a pool service. And then we can handle it in a special way. There are also other ways.
So if you had a repository pattern, and you've got an iBooks repository interface that's backed by a DBContext, then you would basically say register the iBooks repository as a service, and then GraphQL would go through that, and everything would work without direct reference to the DBContext in your application, right?
Exactly.
Awesome.
So this is now very transparent and gives you the ability to get actually these resolvers now a lot cleaner, removes these implementation details about how they are hosted in your dependency injection, and then give essentially a more cleaner code.
Very
base.
nice. So I'm curious, and we're probably going off script here. Had we registered the DBContext not with a factory but as a transient service, would you then be able to do that without serialization because you would request a new? Okay, so that's another way to approach it too, and of course you can use DBContext pooling for that as well. So you could have DI basically serve up to you transient instances of the DBContext from a pool, which functionally is very similar to what you're doing with the factory, but depending on what you're actually doing, maybe easier for some people.
Yeah, and there's actually a third way And that would be the resolver level DBContext, which means we will create a service scope for resolvers that have
right.
a book context.
Yes.
And the same works for the services. And with the service, you can also implement like an object pool of T, and we understand that if we get that from the dependency injection. So there is a lot of things that we can now handle and take out the complexity from doing more performant or more scaling APIs.
I think there's kind of an important kind of point about DI here, DI in general, but maybe DI specifically with EF in this case, which is, we have add DBContext, which does a standard normal thing that's easy to use in web applications, but there's a lot of other stuff that you can do with DI. We have the different add DBContext methods, the pooled one, the factory one. There's different scopes that you can use, and DI is very powerful for doing lots of things. So sometimes people kind of assume that you need to resolve a DBContext directly out of DI, but no, you can resolve a repository, you can resolve it as transient, you can resolve it as scoped. I would not put a singleton DBContext in DI. I mean, you can if you want, but that's usually a bit of failure. There's a lot of different things you can do with DI. It's well worth kind of looking into some of those patterns.
Yeah, and that's one of the things. So the where we see the most failure with DB context or with entity framework is when people build these repositories and try to live just with one thing context.
Yes.
And that is
a singleton context behind a repository is not the way to go. It really isn't, people. It really isn't.
But and that's on the other side. When we looked into performance with .NET 6 and also pooled, it's we have GraphQL examples where it's 6 times faster now.
Yeah.
And then before. So
it's worth stressing, even regardless of GraphQL, that DB context pooling is something that if you really care about performance, you should at least look at and measure if it matters in your application. So knowing up, creating, instantiating a DB context every single time you want to do a query and then disposing it might be surprisingly be heavier than you think, basically. So just keep it in mind.
But now I have to put the opposite side to that, as I always do when this comes up with Shai and I, which is, if you're doing a simple thing, so if you're doing like a single GraphQL query, or you're doing, you're making a single query to the database and returning them, then that's true. The DB context pooling helps. If you're doing anything where you're doing, a significant amount of change tracking business logic going on, it quickly becomes negligible.
Yes.
The services behind DB context already have a caching mechanism for, built in. The model is built, DB context is designed to be newed up. So the pooling really can make a big difference. But as Shai said, measure it, because if you're not doing just a super simple thing with the DB context, as soon as you're doing something complicated, then it quickly becomes not the bottleneck, and instead it's all the other stuff you're doing that becomes the bottleneck.
Yeah, there are a lot of things that you actually have to look into, like if you need tracking or stuff like that.
Yes, exactly. Yeah.
Oh, absolutely.
Okay, so this is just the query part. It's now a lot sleeker. You can see also it integrates very well in the new minified API, and makes really it essentially looks like you're just writing a C# class, but out you get a full GraphQL server that produces, as you see here, SQL from your query. So I just queried for title, and we got a query that really just asked for title from the DB.
I want to triple, quadruple, whatever the next iteration of that is, emphasize that, because that is, to me, the most powerful aspect of these two married together, is that projection goes all the way down to entity framework, right? We're not grabbing everything from the database and then selecting what we send to the front end. We're literally piping it all the way down. And this means that as a front end developer, I can make changes and not wait on someone to change the server, and not worry about those changes being inefficient. I mean, I still should look into it, and there's nuances, but the fact that it passes the sorting, the projections down to the database level is so key, and that's what makes it very different from a lot of other approaches.
Yeah,
and,
and I want to just call out as well the question that was already answered in the chat about Cosmos DB. You know, we're showing. I assume is this going against SQL Server, Michael?
this is actually SQLite at the moment.
SQLite. But that's the point. Like, we've got these different providers, so this isn't tied directly to a certain relational database or even necessarily a relational database. If you wanted to, this could be a Cosmos DB server behind it. Everything would still be the same. Cosmos DB has different capabilities than a relational database, so make sure you are using the right tool for the right job there. But you've got that abstraction and that common patterns behind it, so now you can tie all of these things together and basically have the same experience.
Yes, and I mean, we are using in a lot of projects. We are using Postgres, for instance. It works the same there. So that is really the beauty of Entity Framework. And to really make the point here with Entity Framework, this is actually a demo my colleague Pascal built for me, and it is a more complex DBContext, which uses inheritance and stuff like that. So we have again a book context here, and we have some publications, authors, readers, and so we have inheritance built between these. And actually, if we look in our configuration, it's a bit more complex. We have an interface, so we use a class publication here as an interface. It's actually a type, so an entity. But we say in GraphQL for us, it's an interface. And ebook, paper, and magazine actually inherit from this type. So this didn't work with Hot Chocolate 11, but now we understand also these things from Entity Framework. So what we can, let me just run that. And just to have a look at the query. Again, it's a simple query. We're using here our book context and have sorting stuff on it, and we have configured it here to be a pooled DBContext. So very simple. And now let me just go into this demo 4 actually. We skipped one. I have to make up later for that. So what I did here is essentially we have a simple query. So get publications. That maybe is just a list of infos what publications we have. So if I query that, let me just pick up the query. You can see we have here now a query that builds up the SQL for us to get, this is paginated call, so we have also a limit in here. And essentially we're grabbing some of the data. But now that we made GraphQL aware of all the interface dependency and stuff here, we can see that we actually can ask our publication here for if it's a book. If it's a book, we want the author. Or if it's an ebook, we want to get the reader name. Or if it's a magazine, the schedule, or if it's a paper, maybe the field of research we are drilling into. So if I execute that now, and this is a fairly complex query now, then you can see, depending on the type here, this is a book, or this is an ebook, we get different shapes of data. And if we look at the query here, now we just changed the GraphQL query and Entity Framework. I mean, we translated to expressions, but Entity Framework figured out this fairly complicated query and built us just the thing we need to fetch our data. And when I saw this demo, I thought, hey, that's really crazy with what complex queries Entity Framework manages to still get some useful SQL out. So
very cool.
Yes,
yeah.
Excellent.
So yeah, also with very complex Entity Framework DBContext, you will get a beautiful GraphQL API where you can drill in and look at all these connections.
That's
Oops.
super cool.
So
Yeah.
the nice thing about GraphQL too is that we allow for edge scenarios. We were talking about Cosmos DB, and there's some link queries that are just too complex to translate right now, and you can drop down to raw SQL. And what I love about GraphQL is you can build a resolver for that piece of the query that requires that, but you can still use the rest of the stack for the other parts of that, and it all just surfaces as a single API.
Exactly, and you often have that. If you think about scenarios where you now drill further into the data, and it might become too complex, so you have a resolver here to get into another shape, and then it maybe use a data loader or something else. So there are a lot of constructs that you can use to handle those scenarios.
Yeah, that seems very powerful to me. The idea that outside you expose like like a graph, like a thing, but then the actual specific nodes inside the thing that's being queried, you can have the generic thing and people just compose over it, projections, filters, or whatever. But you can also decide to override, as one says, to override it and provide your own custom implementation, which, for example, would be a lot more performant if that is a very specifically hot kind of API point for you. Right, so that's invaluable.
Yeah,
and that's something that I know I get asked a lot about, comparing GraphQL to OData, and they're similar but they're different, and they serve different purposes. And to me, OData is a lot more about serializing a query over the wire, whereas GraphQL is different in that it explicitly allows you to specify how the runtime resolves the bits of the query, and that's a subtle but very important difference. You can obviously just hand it off to an iQueryable, but you have that built-in flexibility to control what aspects of it and how you retrieve them.
I see this kind of collaboration of different technologies as a real example of how polyglot persistence works in the real world. I mean, I don't know, for those of us who remember back to what seems like quite a long time ago now, when NoSQL was like, oh, do NoSQL, and other people are like, no, but relational is better for this, and there's different tools for different jobs, and I may be getting this wrong, but I'm sure Martin Fowler at one point wrote a blog post or something about polyglot, saying, right, well, yeah, you got different data sources for different reasons. Like maybe this part of your data source needs to be in a Cosmos backend or in Mongo or just in a text file somewhere or whatever, and the rest of this needs to be in a relational, and this bit should be in a key store or whatever. And that all makes sense. But then being able to tie it all together to a single API, which the consumer then uses, but which splits out to the different parts on the end, is I think, to me, a real concrete example of actually being able to use polyglot persistence in a real world kind of application, which I think is very cool.
Yeah, and just to make the point here, so as Shay and Jeremy also mentioned, you can put in these resolvers. This could also be like you have a couple of things in your entity framework, like this magazine is in our entity framework, but maybe you have data somewhere else.
Mm-hmm.
Maybe in files, maybe in a blob storage, whatever.
Mm-hmm.
So it's very easy to extend this magazine type without actually changing the magazine type. So we could introduce a new type that is maybe our magazine I'll just copy that magazine. Let's say there's an info about our magazine, so we call it the magazine info, and this type actually in GraphQL will extend the magazine type that we have here. So I don't have to bind it to the type. I also could specify a name here. You can see I also could define the GraphQL type name, so that it could be very loosely coupled, could be in completely separate assemblies. And then I can introduce a new resolver here that now gets us some extra data. Let's call it info about our magazine. This is an info. And this is how easily you can essentially extend now the model that we have from Entity Framework and enriches with data from somewhere else. So the one thing we just have to do is add type extension here
Hmm.
and then put it in. Run our server again. And our schema has changed, and we have now, we are resolving data from Entity Framework and then are able to extend it from,
That's very cool.
yeah, there you can see the info and would now get the info as we need it.
Wow.
No, I ran the upper part.
This thing where you have what the model you expose in GraphQL is fundamentally it's coming from EF Core in this example, but being augmented with non-EF Core things I find also very powerful. This idea that you can I'll use the word stitching, which you use in a different sense usually in GraphQL, but still I'll still use that word. You stitch together like an EF Core model with another extra stuff, right? That's coming from who knows where. And presenting all that to to your consumer, to your GraphQL API consumer, that's awesome.
Yeah, and that's really empowering. You have this data, and I mean, you have lots of data sources in your everyday life, and you can just bring them together. Like Nick Schrock, one of the GraphQL inventors, one of the 3 person that came up with the GraphQL spec, said GraphQL is a bit an overcompensation of the microservice architectures. Like GraphQL is this one graph that you have to explore and query all your data. And that's what a lot of people love. If it's data scientists or front-end developers, they can just go to this one graph. Behind this one graph could be microservices that are very, very small services all over the place. And you just bring them together in this graph and makes them accessible to the user.
That's one thing. I've been doing a lot of research of GraphQL and talking to a lot of developers about it. And the one theme that surfaced is this idea of a single endpoint and the ability to create it as a facade behind other services. So a lot of developers who are modernizing applications are writing resolvers for their backend APIs. They're saying we don't have to rewrite them just yet. We can expose them as GraphQL, and the resolver just talks to WCF in the backend or whatever that legacy is. And it's pretty amazing to see those themes surface across the board.
Yeah, WCF is a good example because WCF has these huge data, often these huge messages that would take a lot to send over the wire. But with GraphQL, you can essentially put a GraphQL server very close to that old API. So you have unlimited bandwidth between your GraphQL server and this WCF server. And then you just send down the data that the user actually requested from that WCF service. So that's a very good optimization. And still with this old server, you can get a lot more performance than now. Okay, let's have a look at some new GraphQL features. And that is Hot Chocolate is one of the 2 first GraphQL servers to implement that. That is called the Defer and Stream spec. And that allows you to deprioritize parts of your query graph. Just switch the demos here, and then we have a look why this is so cool. And it's actually not a new idea to GraphQL. Facebook uses this actually for years. Just let me get that up, and then I explain a bit. So Facebook actually uses defer and stream, and also there's a third directive in that regard. It's live for years in their graph. So the main problem that Facebook has is with GraphQL, it's awesome to fetch everything in one go. And that makes it very efficient to get all the data that you need for UI components maybe in one data fetch. But it also introduces a problem. If you have in your data graph maybe some resolvers that are slower. For instance, Facebook fetches the news stream, and they all have the comments. What they want so that the site appears to be very fast is first get the news, and then one by one get the comments without the user even noticing them. And that's what stream and defer is about. Let's have a look. So I have a very slow resolver here. It's my query. And it essentially gets books again. One thing is here that we take the books now as an async enumerable. So we essentially wait for each over our data, over our DB set. I built in here a very bad de-optimization. So each iteration costs us 500 milliseconds. So let's run that.
De-optimization. That's good.
Yeah.
I like it.
We should get some of
Dragon.
those into our products.
Those are good,
Yeah.
so you can remove them and say, "Look, we've become
Exactly.
90% faster."
It's like the when you used to have the turbo button on the PC, right? Because the new PCs were too fast for the code written, so you had to slow it down.
I have to admit, the first PC that had a turbo button on, I had no clue what it was doing. I was like trying to figure out, like, okay, what's faster or slow? And I pressed this button, I'm like, I don't know what's going on here.
But I had to put the turbo mode sometimes out. So run the PC slower to play certain games.
Yes,
Yeah.
of course, yeah. Like that game that you started on a 486, and it was designed on an 86, and it like suddenly everything's just zooming
Yeah,
around.
it
the
was
screen.
using the
Like,
CPU cycles for timing.
exactly.
Yes.
Yes. Back to the modern world.
Good times.
So I'm running now my GraphQL query, and you can see it's not the fastest. It's coming now 6 seconds. That's very
Okay.
bad. So what can we do here? So GraphQL comes with these new features. They are actually pre-draft stage. So they're in the proposal stage at the moment. They will come, but there are a lot of spec edits. So, but anyway, they are already quite stable. We are iterating at the moment on the spec to refine them. So with every new GraphQL server from Hot Chocolate, you get a new set of these implementations. So what we can do is now say stream. That's the simplest usage of stream. And now look what happens. I get them one after the other, meaning the data is streamed down to me. And if we look at the transport level, we can see that we have patches. First, the GraphQL server will send me down over the same HTTP connection the empty graph, because I said I want to stream this piece of the query. Then I get a patch, and you can see that it tells me, okay, this piece of content actually belongs into books, and it's the first item essentially in that list. And this is the data that you have to patch in that list.
Nice.
Very cool.
Is it so? Is it true? So I'm assuming that you're actually streaming all the way from the database. So EF Core itself also returns an async
Exactly.
enumerable, right?
Exactly. That's why I said it's an async enumerable.
So that's I want to make sure everybody understands this. If this is like a super complicated, heavy query at the database side, so the SQL actually requires your database to work a lot. Every time your database produces a row, then this gets handed back through through Hot Chocolate all the way to the client, which I find extremely impressive. Having this end-to-end streaming, very cool.
Yeah,
So-
the cool thing. So how we support that is essentially that you say in your resolver that this resolver returns an async enumerable, and then we by default support end-to-end streaming. If you don't have that, we will emulate that. So essentially build a task around that and stuff like that. But for data source like Entity Framework that support that, we really have an end-to-end streaming.
So in the client, does that just look like a callback that gets the updated data as it come in?
Oh, it's essentially, if you look at really what's going on the transport level, so Facebook has this problem that it has to run everywhere. So how that works, let's look at the transport body. Do we have that here? Yeah. When you look really into it, you can see that we have a chunked encoding.
Mm-hmm.
So we update the stream in chunks, and we are sending down a MIME stream. So it's like this content parts, MIME parts that we send down. So it's a standard HTTP connection. There's nothing special. There's no socket involved. So it works everywhere, and works also on without any pub/sub stuff. So it just works.
And because of the beauty of the way async works in .NET, you're not consuming a thread the entire time you're doing this. Basically, when you don't have anything coming back, the thread is in your state pool or going off and doing other things, and so that's the beauty of the async await and for each async there. As Shai says, going all the way back to your database server hasn't got anything for you yet. You're not consuming anything, so. Great for serving multiple requests from the same server without using up all of your threads.
So
I'll just one thing. So there's a very pertinent comment here by Dick Baker on order by. So it's true that if we're talking about, maybe we can highlight this question. So if you're executing a SQL query that has order by, then the database cannot give you back results until it's gone through the whole thing, right? If people think about this logically, when you say order by, you're effectively asking the database to go through like the entire set, and it cannot start returning any rows before it's seen all the data set, because there might be a row that should come first, right? So in that kind of case, you would still be streaming everything from the GraphQL side, but the database side is no longer streaming, right? It's going to give you back like the entire result set in one go. So the end-to-endness is going to be cut at the level of the database, unfortunately. But not all queries require order by, right? So that's a pretty important thing. And I'll just add one very, very small thing. This is actually this whole streaming versus buffering, what we sometimes call it. A lot of EF Core users are kind of like not aware of this. So we sometimes see a lot of people, you do an EF Core query, not in GraphQL, just in normal C#. And at the end, you put a to list, right? Or a to array, or maybe a to list async if you're doing async. So it's important to understand that when you do this, you're basically telling EF Core, or you're telling .NET to take all the results back, buffer them in a list, and put them in your memory as a list. Whereas instead of doing this, if you did for each or await for each, for example, or if you use something like as enumerable, you can stream those results as they come back from the database, exactly as we've discussed here in the GraphQL context. So this thing, it's always worth thinking about, how am I getting my results back from the database? However,
I want to again come in with my opposite side of the fence on Shai on this. That doesn't mean that using to-list async, for example, is not worthwhile. Because again, async is also about not having your threads be blocking while you're doing that database access. So your database access might be taking a while to give everything back. And even though you would want to use it as a list when it gets back onto the client side, it's still very useful to do that as an async request to avoid, blocking threads the entire time you're doing that. So,
absolutely.
Yeah, it also takes just time to produce the results, like they must be formatted, processed.
Yes.
Right.
So there's more to this. So I can also say like
more.
I can also say maybe, okay, this initial request, if you look, it's 39 milliseconds for my first response, whereas without stream we had to wait 6 seconds. I can also say, okay, maybe I can wait a bit, but I already have the first item to display on my web page. In this case, you can see it was immediately there. We have first initial response for the first byte, which is 550 milliseconds. But I get the first item, and then it streams the rest. So you can also tell the stream which items you want immediately from the stream and which items you want to defer. Okay. So, but that is just stream. There's also defer. So let's change our resolver a bit to make it deferrable. So actually for defer, there are no preconditions for defer, but I want to make the performance of our query even worse. So we're going to write a little extensions for our book, and let's call it extend object type, and then we extend actually the book type here. And this is book details maybe, and we put in a very, very slow resolver that gets some details. I don't know what details, but let's just maybe this is another 500 milliseconds just to make my point. And then we return hello. Okay. Async. So this is very slow now. And we are integrating that into book. So this is actually then queryable in our streamed list. So let's just hook that in at type extension. This. Okay. Let's fire up our graph.net run and see how that turns out. Okay, so this is up. Let's just refresh our schema. And then we should have now details here. And this is our very slow field. And this is where we stream our stuff. But still, like now for our first result, we need 2 seconds. And then also all the other parts will take a lot of time. I think I have a bug. This is, as I said, preview 14, which comes out at the end of the year. So we will fix maybe this little bug. But anyway.
So the dangers of live streaming.
So what we can do here is to make that faster is essentially defer this field. So we can say this shape, we want to actually defer. And defer will essentially spawn another task off. So this, we are streaming now and deferring this field, which will give us the first item, but the first item will come without details. And then it will start streaming and deferring and swapping between these and resolving the data very asynchronously. So let's try that. And I hope you can see how it completes now. So these fields are now put back.
So this is very, very, very pertinent for front ends, right? On my mobile phone, where the networking is bad on whatever 3G and so on, then the idea here is to get the essential data on the user screen very, very quickly, and maybe get the rest of the data a little bit later or something like that, right?
Yes.
This is very front end thinking kind of.
Yeah, it's essentially the front end before that could just do a query, and then it was slow. But now we give the front end a tool to essentially tell the server to deprioritize certain sections of the query. And the server is allowed in the GraphQL spec to essentially ignore the defer. So if I, for instance, would defer title, but title I have in the moment I get the book. So the server might know title is already there, so deferring it will actually make the query slower. We can skip that and just return it.
So, Michael, what does this do, by the way, in the context of an EF core query? If, say, I want to get a book and I want to and I put defer on a specific attribute of a book, like knowing SQL databases, obviously, what does that mean here?
So if the query is projected, if we have a big query, we essentially will project the query and skip the defer in it, because we know we have the data when we do the first query.
Right.
But we are essentially working on splitting the queries then, and then just fetching subgraphs. But that is coming next year. We are working. I guess I think Entity Framework also has a capability to split out the queries, and that is essentially what we do.
Yeah. Yeah, we call this split queries in our world. Yeah.
That's essentially what we are working on, to really spawn them out. At the moment, we would ignore the defer because we know it. We essentially have the data there, but we are getting more and more into this projection stuff and making it more intelligent. As far as defer works, so stream to efficiently work needs an async enumerable. Defer needs nothing. It just needs some deferrable thing. So something that costs time, and then we can put it in another task. And if there would be another query, if details would query something else, like really have a data resolver that does something on the DBContext, you could see that the SQL would run a bit later. And if we look into logs, then you can now see here we have 23 patches. So you can see first is the first book's coming, then actually the second book is coming here. And then you can see there's the details coming and so on. So you can really see how the data patches are coming.
So we had a question for the front end, like what does the fetch look like? What does the code look like that's managing the defer? How is it handed off the pieces as they become available?
Depends on your client. So we are working on, so this is really, really cutting edge in GraphQL. This is a feature that is coming maybe into the GraphQL 2022 spec. As I said, there are a lot of things we are working on in the spec group, but there are clients in the JavaScript world, like Relay supports it already. I don't know what's about Apollo, but essentially they will patch these graphs and complete the models. So what maybe I didn't show here is there is something called a label. And Relay will use this label to label certain sections of the data. So we essentially, with this, would label this selection set. And then when this data comes, it knows which component to update in Relay.
Okay.
Do you know yet what this would look like in Strawberry Shake?
Yes, I'm working on this, but we're experimenting with this because it's
in design.
It's a lot more complex with static types.
Sure.
But we have a couple of ideas. We have also a couple of prototypes I'm working on, and maybe end of the year we will release the first bits. So we are experimenting with Maui, and I'm talking there a lot to Brenton from the summary stuff at Microsoft, and yeah, we will see. We'll see. But it has a lot potential to really reinvent how UIs will work, especially with Blazor. With Blazor, it's actually more easily done than with Maui.
Exciting.
Interesting.
So what I want to see now is I want to see SQLite in Blazor WebAssembly running GraphQL as on a server in the WebAssembly, so my application could be accessing SQLite through. No, sorry, maybe going too far, but
I don't think you are actually. But
you are laughing, but I did a demo once with that. But
wow.
So what we're actually doing also with Strawberry Shake, if you're using Blazor, we already have like subscription supported, and so it's it's a reactive approach to data, and we allow you to store data on the local data on the Blazor application in SQLite. So that works quite well already. But let's not dive into the wrong direction now. I have one more thing on my list. This is Defer. As I said, experiment with it. So who has fun? If you're using GraphQL if you're using JavaScript front ends, there's already clients out there that support that, Relay at least. And next year, maybe January, you will have Strawberry Shake working with that as well. Okay, so demo 3.
This is the final demo of the year, so no pressure.
Exactly. So this is about, it's preview. The 12.4 will come out at the end of this year. So we are still refining things. And this is about mutations. When people come to GraphQL in .NET, then they get sometimes upset how much work mutations are. So in GraphQL, mutation actually consists of 3 parts if you want to have a well-designed schema. We call them the mutation. So that's the mutation. Essentially, one of these methods is a mutation. And that changes data. So in GraphQL, we have queries, which are side effect free, and they allow you to just read data. They are very simple. We saw that. But then we have mutations that change data. They are not side effect free. And the mutation, as I said, consists of the mutation, here our resolver. It consists of the payload, which represents our data. And then it represents on the input. And the input is another object, which gives us the data. Let's just have a look at the GraphQL side. And then I explain about this pattern a bit. Okay, let's just go in. Okay, I haven't prepared a sheet for that. Let's get here. Okay, so my mutation in GraphQL starts with a mutation, and then I can go into my author and essentially specify my input. So why is there just one input? That's a pattern that was established by Relay. It makes it very easy from a JavaScript client, for instance, just to pass the JavaScript object into essentially a GraphQL variable that you would use. So you just have one thing. You don't need to spread it or transform it. That's why we actually have this pattern of having a single input here. So in this case, I want to create an author. Let's call him Michael. I'm not an author, but make me one. And then I have a payload. And the payload, in this case, looks a bit silly because it only has the author. And in GraphQL, we return the author because the mutation is what changes the data. And everything that is now in this selection set down here is the ability to query the changed state of the server, to query the changed author. This could be useful, for instance, to maybe query for the ID from that author, which we just created.
Database generated data, for example, in our relational world, like
Yes.
an ID that's auto incremented, identity, whatever, all that kind of stuff. You're getting it. You posted a new author to the GraphQL server, and at the same time, in the same round trip, you're getting back that data that was generated.
Exactly. And what we also have here, and that makes it even more complicated, if I would code that out, user errors. So GraphQL has errors, but the protocol errors are more meant for the developer. Maybe database was down and stuff like that. But everything that is user-driven, like maybe I'm not allowed to have author with just 2 letters here, then I would essentially throw a domain error. And these domain errors are also designed into the response, so I would be able to query for the errors.
Mm-hmm.
So you can see that is a lot of data and objects I would have to create, and that's often where people that are new to GraphQL find it a bit clumsy. So what we thought is getting rid of these things and making the .NET side again clean. So essentially, we would like to write our mutation let's do an author here. And as an input, we essentially, in this case, want just the name. So we can just inject what we have or what we like. So we just inject the name. And now we sacrificed our schema design for GraphQL, but let's just run with that. So then we just pass in the name and to get rid of all these kinds of things. Yeah, let's kick that out. So now our mutation looks a lot less cluttery. And then we might have maybe some custom domain errors that we want to throw in.
I know. Minimal mutations. Right?
Minimal mutations for minimal APIs. I like it. Let's run with it.
Cool.
I could be okay with that. So so maybe we just throw, because I don't want to waste too much time. Let's throw an exception, and this exception we call maybe we just say okay foo, because something went wrong in our mutation. So this is essentially, if we look at it now, just a C# method again. We can live with that. It's just what we would do on our repository, maybe even compose our repository now in that way.
Much more idiomatic to what you would expect in C#.
Exactly. So what do we have to do to make it a cool GraphQL API? So the first thing is we opt into something that we call mutation conventions. So what it does is essentially taking your standard C# stuff and making it and GraphQLify it. Make it awesome for GraphQL. And we give you a control. So these attributes are not fixed. We are still working on them. So essentially, I want to have just one attribute. But at the moment, you can specify payload here, so that you tell the engine, generate me a payload object for my mutation, and also generate me the input object for my mutation here. Last but not least, I maybe have an error, and this error is an invalid operation exception, which makes no sense, but let's say that.
Every error is an invalid operation exception. That's our philosophy. No, sorry.
So still iteration. I think in the next build, it will just be one attribute that you need to use. I mean, you could have multiple errors. We can see that in a bit. So there will still be the error attribute. And what we want to also allow is to have none of these attributes. Essentially give you a way to say, okay, infer everything for me. I'm just writing simple code, simple C# code, infer everything, make it GraphQL nice, and then you don't have to annotate anything.
So concretely, the idea here is that you guys would look for example, in the EF core model to know which property is database generated, and that would implicitly be returned in the payload, for example? Is this like a direction you're going to?
We would essentially, you would tell us that something has mutations, and we would merge it into the mutations and make it a nice GraphQL mutation. Yes.
Okay.
So essentially, you would still need this mutation class here, and say that there is an author mutation. Maybe it's a repository that you have written, and then you give us this repository and tell us these are my mutations on the repository, and
So
then we would infer from it a mutation type. Yes.
So you're inferring based on the return type and the parameter signature what the input and payload are.
Yeah. You can see I'm now just returning here author, and I'm getting in the name. I also get in the book context and cancellation token, and I'm throwing here an invalid operation exception. So what comes out now, let's just refresh that, is that it's the same. So I can now execute that, and actually I get an author, but I don't get an author here because an error happened here. But GraphQL didn't display the error because I didn't ask for the error. Because now I actually can ask for the errors here. And GraphQL actually will also tell me that when the error, I can either query for all errors, like because that's an interface, for instance, give me all the error messages. Or I could now say, because we specified it, give me the invalid operation error. And if my exception had some special properties that I want to expose, we will also infer that correctly and make it a nice error experience here. And then I essentially can query it, and I can see, okay, that's an invalid operation error because we threw that there, and it has a message through. So it's much more natural for GraphQL, for C# developers now to write these mutations, but you still get all the GraphQL benefits. Like it looks like proper GraphQL. It's all the schema best practices that you have.
Love it.
And yeah, so we are making the experience even nicer with the next release for Entity Framework and GraphQL in combination, and also everything else you can bring.
So I think we're a bit over time. So
sorry for that.
No. It's fine. We like going over time. It's always
we always go over
more.
time.
Yeah, we always go. It's always better to have more. I just want a couple of, obviously, if you guys have things to say as well, a couple of things to end with. First, I just wanted to show this comment. Junior dev, I have no idea what's going on, but I aspire to understand what's going on. I say we've all been there, and most of us are still there a lot of times. Don't think that everybody here understands what's going on all the time. There's a lot of stuff that I saw today. I'm like, what's going on there? What's that?
I just nod my head personally. I don't,
Just say,
I don't know
oh
about you
yeah,
guys.
that's great. That looks really
Exactly.
But keep going. It does get easier to understand, and then you go on to something new, and it's hard again. But it's worth it. And then I guess I have one final question for Michael, which is chili cream, hot chocolate, banana pop cake, and strawberry shake. Your names. Where do your names come from? What made you come up with those things?
So essentially, we were looking for names, and I always liked the way JavaScript libraries do it. They have some nice like gulp and strawberry GraphQL or stuff like that. They have very funny names. And when we were looking for a name, we were at Starbucks, and my son, every time he goes to Starbucks or every time he sees a Starbucks, he says, "Daddy, I want a hot chocolate." And then my brother essentially said, "Let's name it hot chocolate." And when you have a library,
every time
like
you go for GraphQL, you grab a hot chocolate now, right?
Yes. And now we essentially called it because my son liked hot chocolate from Starbucks, and then we came up with other things like Starbucks has these cake pops. I don't know if you know them. Every time we
so you can get banana pop cakes from Starbucks? I was not aware of that.
Yeah, but they have banana cake pops and they have strawberry cake pops. I have to get to the US at some point.
Very cool.
Good to know. Good to know.
Yes.
Yeah.
Okay. Well, thank you so much for joining us, Michael. This has been some really inspiring stuff here. It's really great to see GraphQL on .NET working like this. And thank you, Shai and Jeremy, for all the time this year we've done these stand-ups, and everybody for watching them and generally being quite nice to us, which is always helpful. We're gonna take a break over what's the holiday season for most of us here, and then we'll come back next year with lots of new good stuff. So if you have suggestions about what you want to see, go onto the GitHub repo. There's a pinned issue at the top, and Jeremy's got his festive cheer there as well. So we'll say goodbye and see you all next year. So thanks very much for watching. Who's doing
Bye,
that?
everybody.
Who's doing the let's get out of here thing? Is that you, Jeremy?
That is me.
Okay.
But I thought I'd let us waffle around for a little bit longer.
Yeah. Okay.